Okay, so I have a work solutions for the 4.3 chord lengths, including Pythagorean theorem. I'm going to work through some of these for those of you who need a little extra help. Things to note here. First of all, anytime we have a right angle with a segment perpendicular to a chord, it bisects the chord. So I can write 10.3 right there. If there was anywhere else where there was a radius, they would also be the same. You don't need to do that every time, but that might help you as you look for stuff. Okay, so I'm trying to find the hypotenuse, have a right triangle, and 10.3 squared plus 5 squared equals x squared. And so you can finish that with Pythagorean theorem. You can use your calculator, find out what the missing values are. So 10.3 squared is 106.09 plus 25 equals x squared. So that would be 131.09 equals x squared. Then you're going to take the square root to simplify. 11.449 says round your answer to the nearest tenth, so 11.4. Going to the second one, again, notice what is equal. If there's a perpendicular, then these are equal, so that's x and that's x. And every radius is equal to every other radius. And so you could write 11.2 here, 11.2 here. That's not necessarily important for right now, but it might help you at some point. So what do we know? Do we know 2 out of 3 sides in a triangle? If so, we can find the third side. So we have x squared plus 7.2 squared equals 11.2 squared. So this is different than the last one because this time you know the hypotenuse. So you square this hypotenuse. Don't start rounding until you get to the end. So I have x squared plus 51.84, subtract. Good time to use a calculator. And then take the square root of your answer. 8.579, which rounds up to 8.6. Okay, so very similar. You can check the answers for these. This one, we're just going to show the setup and not finish all the way through. If you need more help working all the way through, you can ask for it later on. Right triangle. I know this is 15.1 because every radius, we highlighted the radius, every radius is congruent. So x squared plus 13.3 squared, 15.1 squared. Go to this next one. What do you know? I know the hypotenuse is 12.5. I could write it there. I know this 10.4. I could write it here. Either triangle, 10.4 squared plus x squared equals 12.5 squared. By the way, there's the answers. Keep going. Nothing is really changing very much here. Only now I have an x that is a little bit further down the line. So I got to figure out, it's kind of a two-step process. This is one that will be a little more tricky because you can't use the x in the Pythagorean theorem. So pick a different one like a. And so I know enough to find what a is. So a squared plus 12.6 squared equals 14.6 squared. So do your regular Pythagorean theorem. 12.6 squared is 158.76. 14.6 squared, 213.16. A squared equals 54.4. A equals 7.3756. So basically 7.4. says around it. So that means I can look at my picture and put 7.4 as this distance right here, because that's what A is. Well, this is why when you get stuck, you highlight the radius, because this whole thing is the radius. And I know by highlighting this radius, I don't think they look the same length, but when you highlight them, you can notice it. It's kind of an optical illusion when they're not. That whole thing, in other words, x plus A added together adds up to 14.6. So we just found A is 7.4. That means X is 7.2. There's your answer. Number 6 is again the same kind of problem. Pick a letter there, find that missing side. The difference with number 6 is that they give us the diameter is 32.2. So we're going to have to take half of that to get our radius. The radius is not 32.2. The radius is half of the diameter. So half of 32.2 is 16.1. So then you're doing essentially the same problem here where you find the one piece and then find the other. Okay, 7 and 8 also same type of setup. If you notice, number 7, you're trying to find the radius first. And we also know that this is 12.6, so this has to be 12.6. So we're going to find this little triangle before we can find out x. This one seems a little crazy, but every radius is equal. So you can draw in your own radius and put the 16 on it. You could draw one here and put 16 on it. And now you have essentially the same problem as the other ones. That is page 1.